Hello, welcome to our lesson on trigonometry. Alright, we are going to look at the concept of trigonometry or introduction to trigonometry. Alright, then we shall continue from there. So let's look at the introduction to trigonometry. Okay, so with the whole concept of trigonometry, all right, so it's an aspect or branch of mathematics where we study how we find what the side, okay, or the length and the angles of what of a triangle. Okay, so when you are given a triangle, how to find, so if I have a triangle, okay, trigonometry deals with how I'm going to calculate for the side, okay, and then the various angles within what? Within the triangle. Okay, so that is about the whole concept of trigonometry. All right, so we have the three basic trigonometric ratios. Okay, though we may have the inverse of the basic trigonometric ratio. And the three basic trigonometric ratio, we have the sine, the cosine, and then we have what? The tangent. Okay, we have the sine, the cosine, and then the tangent. And we may have the inverse of this. Okay, where the sine is the cosec, the cos is the sec, and then the tan is the cot. Alright, but we are only going to look at this. We will not look at the inverse. We'll consider the inverse in another aspect of trigonometry. But today we are only going to look at these three basic trigonometric ratios, which is the sine, the cosine, and then what? The tangent. Okay. And then we will also look at a right angle triangle. So when you are given the triangle and it's a right angle triangle, then we have what we can apply. And if it is not a right angle triangle, we also have what we can apply to solve for the side and then what? And then the angles. Okay, so let's consider a right angle triangle. And what is a right angle triangle? So let me consider a right angle triangle is a type of triangle where we have one of the interior angles to be 90 degrees. So if it's a right angle triangle, let's look at how you can apply the three basic trigonometric ratio to find the angle and the side. Okay, so if I have a right angle triangle, the side opposite the 90 degrees is the hypotenuse. So the hypotenuse is the side opposite the 90 degrees. And then we have the other two sides. This is the height, this is the base. Alright, so the other two sides, one can be the opposite and one can be what? The adjacent. Okay, so it is not constant that this side is the opposite, this side is the adjacent, or this side is the opposite, this side is the adjacent. It depends on how the angle you are considering, okay, where it is being positioned. So if let's say my angle, I'm considering angle theta and theta is positioned here, then realize that the theta faces this side. So this side we call what? The opposite. And then the theta is close or just on this particular side. So this side is called the adjacent. Alright. So this is how it is. So this is my adjacent, this is my opposite. However, if my right angle triangle, okay, let's note the difference. My ABC is like this. Always take notes. The side opposite the 90 is the hypotenuse. However, if the angle under consideration, let's say beta, is here, then the BC here becomes what? The opposite. Take note of that. And the side close to the angle under consideration becomes what? The adjacent. Alright, so this is the difference. Okay, so don't assume that always this side is the opposite and then this side is the adjacent. No, it depends where the angle you are considering is. So if the angle is here, then this is my opposite, this is my adjacent. If the angle is here, then this is my opposite, this is my adjacent. Is that okay? Alright, and if I have a right angle triangle, Okay, there is a way that I can apply what? I can apply the trigonometric ratio and or the relation between the angle and then the sine. Okay, so we are saying that with sine, if I have sine of an angle, let's say the angle is theta. Okay, so the S-I-N-E in short you can write as S-I-N, sine, not sin, sine. Then my sine theta is what? Sine, the formula is opposite over hypotenuse. So opposite over hypotenuse. Alright. So let me say my opposite is O, my hypotenuse is H, my adjacent is A. So that means that I have O over the H. Alright, so opposite over hypotenuse. That is sine. If I also want to consider the cos, then my cos theta, what is cos? Cos formula is adjacent on hypotenuse. Okay, that is the cosine. So that is adjacent over hypotenuse. So the adjacent is a whole of this side, BC. Okay, let's say the BC is A. So A over H, the length BC over the length AC. Alright. Then what is left is the tan, the tangent. Tan theta is what? Tan is opposite over what? Over adjacent. So O over A. Opposite, so my opposite is here, AB over the adjacent BC. Okay, so this side over this side. Alright. If that is the case, we have a short way you can memorize this formula. That's what we call the SO, the Ka, and the Twa. So Katwa, sine opposite over hypotenuse, cos adjacent over hypotenuse, and then tan opposite over adjacent. Alright, so when you get any angle, any triangle, and you want to calculate the angle, you want to calculate the side, then you can go by what? The SOHCAHTOA. And the triangle should be a right angle triangle. So take note that the SOHCAHTOA is only applied for a right angled triangle. You have to take note of a right angled triangle. So the same thing will apply here. Okay. So in here, if I'm considering my sine beta, if I'm considering this right angle, opposite BC over hypotenuse AC. Opposite, so my opposite will be here, opposite over hypotenuse. My cos beta, what is cos adjacent AB over hypotenuse AC. So adjacent is here, AC over hypotenuse. The adjacent is AB over the hypotenuse, which is AC. So adjacent over hypotenuse. And then my tan beta, tan is what? Opposite. What is the opposite? BC. Twa. Opposite over adjacent, which is AB. Which is AB. So if it is here, this my opposite, this my adjacent. Alright. So I believe that you get the scenario for the SOHCAHTOA, how we apply the sine, the cos, and then the tan. Okay, for a right angle triangle. Alright. So let's continue, and then we look at when we have special angles like 30 degrees, 45 degrees, and 60 degrees, how we can find the sine, the cos, and the tan. Alright. Okay, so let's continue and look at trigonometric ratio of 30, 45, and 60. These are special angles. Now we use them to solve questions. Okay, so though we can get these angles, these special angles on our calculator, but this will help us to really understand the concept of trigonometry, how we apply the SOHCAHTOA. Alright, so let's look at it and then move on from there. So let's consider, so if you want to get the 30 and the 60, then let's consider an equilateral triangle of side being 2 units. Okay, so let's draw a equilateral triangle. And then the equilateral triangle, you can pick any unit at all, but the 2 units to make it easier for us. All right. Okay, and we are picking equilateral so that we can get the 30 and then the 60. Okay. All right. So equilateral triangle, or each interior angle is 60 degrees. So here will also be 60 degrees. And here also we 60 degrees. All right. So let's say A, B, C, D. Okay, and the outside 2 units, so 2, and here is 2, and here is 2. All right, so we have this equilateral triangle. All the sides are the same, and if you want to apply the SOHCAHTOA, what we do, it may have to get a right angle or triangle. So let's join from the vertex A down to the base BC. All right, and because this side is equal to this side, the base will be divided into 2. So let me name it as B. You know that here is 2 units. So if you divide into 2, then here will be 1, and this side will also be 1. Is that okay? So 1, 1. And then if that is the case, then here will be 30 degrees. The angle will also be divided into 2 equal halves, 30 degrees. So that now we can get at 30 degrees. We have 2 right angle triangle. BAD, this, because if here is 90, here is also 90, and then ADC, this is also a right angle triangle. So now we can get our 30 and 60. Alright, so before we can find the sine 30 and then, or the sine, the cos, and then the tan of 30 degrees and the 60 degrees, we have to know the height of the triangle, which is what? AD. So we have to find this particular place, AD. Alright. And how do you find the AD? Since we know all the sides, we know here is 2, here is 2, and because the height bisect the base, then what it means that here is 1, here is 1. Okay, so we can use the Pythagoras theorem, and then we can find the height. So we can use any of the right angle triangle. So let's say you can see that from triangle ABD, this one. Okay, what is the hypotenuse? 2. So 2 degrees, 2 square is equal to 1 square plus AD square. Alright, so if I consider this right angle triangle, this is my hypotenuse, because the length is here, so this is my hypotenuse, and then the other 2 sides are there. This is the same as this one. If it is this one, this is your hypotenuse, we have the other 2 sides. So what is 2 squared? 4. 1 square is 1 plus AD square. So 4 minus 1 equal to AD square. And then my AD square will be equal to what? 4 minus 1 is 3. And AD will be equal to what? Square root of 3. Okay, so let's leave the answer in set like that. Okay, so let's leave it in set. Okay, so my AD here is going to be root of what? Root of 3. So the AD is root of 3. So now we can find the sine, the cos, and the tan. So because we have gotten all the sides, okay. So sine 60, let's do the 60. 60 is here. What is the opposite? Sine is what? We have, with the right angle triangle, we can apply the SOHCAHTOA and then TOA. And take note, this is a right angle triangle. So it's the same as this one. So sine 60, sine is opposite over hypotenuse. What is our opposite? AD. What is the AD? Root 3. The hypotenuse is what? Is 2. So if you put sine 60 on the calculator, you are going to get root 3 over 2. The opposite over the hypotenuse. Okay. Then let me look at cos 60. Let me consider 60. What is cos 60? Cos is what? Adjacent on hypotenuse. So if 60 is here, then my adjacent is 1. And then what is my hypotenuse? That is 2. So adjacent on hypotenuse, so 1 over 2. Alright, then tan 60. So what is tan 60? Tan is what? Opposite over adjacent. Opposite over adjacent. So that is root 3 over 1. And that will give me root 3. Alright. The opposite is root 3. Alright, the adjacent is what 1. 60 is here, so this is the opposite, this is the adjacent. Okay. So I'm done with the 60. You can confirm this from your calculator. Alright. Then let's go to the 30 degrees. So sine 30. My 30 is here. So my opposite will be here. If 30 is here, this is my opposite. So 30, then my opposite is 1. And then hypotenuse is 2. Take note, the hypotenuse is always the side opposite to the 90 degrees. So if 30 is here, that's my opposite. If 60 is here, that's my opposite. Alright, then cos 30. Cos is what? Adjacent. If 30 is here, then the AD becomes my adjacent, the side close to the angle. And that is root 3. And then over my hypotenuse, that which is 2. So that is root 3 over 2. And then last but not the least, tan 30 degrees. Okay, so 30 is here. What is tan? Opposite over what? Over adjacent. So my opposite is 1, and my adjacent is what? Root 3. So 1 on root 3. And 1 on root 3, when you put this on the calculator, you see the denominator is a set, so we can rationalize. So 1 on root 3 can be written as what? 1 times root 3. 1 times root 3. And then root 3 also times root 3. 1 times root 3 is root 3. Root 3 times root 3 is 3. So that can be root 3 over 3. Okay, so tan 30 degrees is root 3 over 3 or 1 over root 3. Alright. So I believe you have gotten it. So we can confirm all these answers from your calculator. So we also consider the 45 degrees. Is that okay? Okay, so what is left is the 45 degrees. So the 45 degrees too, let's consider an isosceles right angle triangle with side 1 unit. Okay, so let's consider an isosceles right angle triangle with side 1 unit. Isosceles triangle, okay, mean that two sides are equal. So isosceles right angle triangle. Okay. With side 1 unit. So it means that this side will be the same as this side. Already here is 90 degrees. So when it happens like that, since then here will be at 45 degrees. And here is going to be 45. So that 45 plus 45 is 90, plus the 90 will give us 180. Okay, because it's a right angle triangle and it's isosceles, then these two sides will be 45. Okay, so let me say my A, B, and C. Here is 1, here is 1. Alright, that is the two equal sides. And this side, we don't know. So we are going to do the Pythagoras theorem. So we can say that AC square, this is the hypotenuse. 1 square plus 1 square. And my AC is going to give me what? 1 square is 1. 1 square is 1. So 1 plus 1 is 2. So my AC is going to be square root of what? 2. It means this side is square root of 2. Alright. So that is the case. Then you can now find the sine, the cos, and the tan of the 45 degrees. Okay. So sine 45. And if I'm here, my opposite is 1. My adjacent is 1. And if I'm still here, my opposite is 1, my adjacent is 1. So it doesn't change anything. So sine 45, sine is what? Opposite over hypotenuse. I know this time it is in your head, opposite over hypotenuse. So if I stand here, if I stand, I get the same thing. My opposite, if I'm here, is 1. My opposite from here is 1. So opposite is 1. And my hypotenuse is what? Is root 2. So 1 over root 2. So when I rationalize, I become what? Root 2 on 2. So 1 times root 2 is root 2. Root 2 times root 2 is 2. So I get root 2 on 2. Okay. And then cos 45 degrees. If I'm here and I'm here, the same thing. Cos is adjacent over hypotenuse. Alright. That will also be root 2 on 2. And the last, the tan 45 degrees. Opposite over adjacent. Opposite over adjacent. So that's the same. 1 over 1. And that will give me 1. Alright. So my tan 45 is 1. Sin 45 is root 2 over 2, cos 45 is root 2 over 2. When we come to the 30 and then the 62, sin 60 is root 2 over 2, cos 60 is 1 over 2, tan 60 is root 3, sin 30 is 1 over 2, cos 30 is root 3 over 2, and then tan 30 is root 3 on 3. Okay, so that is that. Alright, so I think from what we have done, when you get a question, you'll be able to apply the SOHCAHTOA and how it is being done. All this can be gotten from your calculator. But I wanted to do this so that we understand well how the cos, the tan, and the sine is being used in a right angle triangle. Okay, in the next time we meet, we are going to solve some questions. This is just an introduction. I know I'll see you again in our next lesson. Bye bye.